Here's the second part. We got 4 more graphs to look at. I just want to make one quick note before I jump in. I did talk about a midline. The midline is going to be a horizontal line that cuts a sine or cosine graph directly in half. And I also want you to know that it's not always the x-axis. So sometimes I have made these little graphs where the solid line will always represent the midline and the dashed line will most likely represent the x-axis if there is a vertical shift involved. So again, midline will always be the solid line in the videos. The dashed line will be the x-axis. Ready or not, let's get going. Y equals 2 plus 1 over 10 cosine of 60 pi x. As always, let's start out with the amplitude. Amplitude is going to be 1/10. The period, it's going to be 2 pi divided by the b value, which is 60 pi, which is going to be 1 over 30, an interesting period. And then the interval for that is going to be 1 over 30 divided by a 4. And I'm going to leave that math to you. We're going to go over 1 and 1/20th. We're going to go over a very small fraction of the time this time. The way I'll graph this, though, I'm not going to be so interested in how far away from the x-axis I am. I'm just going to make sure that each part that I go over will really be equal because I am dividing into 4 equal parts. Okay, my vertical shift, it's a positive 2. I'm going up 2 units. This one is definitely a little bit tougher. We're only looking for one period to be graphed. I had a 1/10 and a negative 1/10 that was going to be graphed. But because I'm going up 2, then that means that I'm really going to have a 2 and 1/10. And then if I go up 2 from here for the negative 1/10, I'm going to be at 1 and 9/10. Which means my midline is going to be at 2. And the reason I know the midline is at 2 is because the midline usually is the x-axis, but I shifted the entire graph up 2 units. So here's my midline. Now the other thing that I need to look at is here's my x-axis. Here for the first time, our cosine graph is not going to touch the x-axis at all. Okay, next. The intervals are going to be 1 and 1/20th. So the first part will be 1 and 1/20th. The second part will be 2 and 1/20th, which is really, I'll just show the work down here. It'll be 2 and 1/20th, which really reduces to 1 over 60. So the second one will be 1 over 60. The third one will be 3 over 120, which is really 1 over 40. So I'll put a 1 over 40 here. And the fourth one will be 4 over 120, but that reduces to 1 over 30. So I'll put the 1 over 30 here. Okay, so let's go ahead and graph this. Usually for sine, we would start at the origin, but since we are talking about cosine, we will actually start at the maximum, but because the maximum is shifted up 2 units, we are looking at 2 and 1/10 to start. Notice again that I am starting at a max and not the min, because the 1/10 is a positive value. At 1 and 1/20th, the midline value will be, the y value will be 2. At 1/60th, the y value will be 1 and 9/10. And then we will go back the other way and end at 2 for 1/30th. Graphing this, we do get this curve. I'm going to quickly show you what this graph looks like on Desmos because this is kind of an interesting graph. It's going to be much smaller than what we usually have. Here's the graph of cosine x, and then we have this graph. And notice that it is just oscillating so fast that it really on Desmos just looks like a thick green line. So we'll have to zoom in here to really see what's going on. And now we can kind of see what's going on. I am interested in just what happens from 0 to 130. So let me go ahead and to 1/30th. So let me do that interval. And this is how much it oscillates in one period compared to the actual cosine graph. So it's kind of funny in that regard. Let me zoom in so we can actually see what's going on though, to check if we have the answer right. Okay, so this is what we have. This bottom coordinate is 0.0167, and that should be approximately 1/60th. So let me just check that. And it is indeed, so this is 1/60th and 1.9, or 1 9/10, and we do have the correct answer. I just wanted to graph this again because it just looks really funny compared to the actual cosine of x graph, when we zoom out especially. Next one, y equals 2/3 sine x over 2 minus pi over 4. I'm going to not even think about diving into the problem yet because I notice my b value is not 1 as it's supposed to. So let me factor it out. We really have 2/3 sine of 1/2 x minus, if I do pi over 4 divided by 1/2, I do end up getting out pi over 2. Please take the time to make sure you understand this. When I divide 1/2 out of both terms, I end up with a 1 here for x on the inside of the parentheses. And then when I divide pi over 4 by 1/2, I do end up getting pi over 2. If that's understood, we'll continue. If it does not make sense, please pause the video to make sure you work with your fractions correctly. The amplitude will be 2 over 3. There is no vertical shift. The period will be 2 pi divided by the b value, which looks like it's going to be 4 pi. My intervals are going to be 4 pi divided by 4, which is pi. My horizontal shift will be pi over 2 units to the right. I'll go and set up the graph. Again, my amplitude is going to be 2 over 3, which gives me a max of 2 over 3 and a min of negative 2 over 3. My midline will be the x-axis. And the reason it will be the x-axis is because I don't have any vertical shift. Now, I do move over pi over 2 to the right, so let's go and plot pi over 2 first. And now let's go ahead and do intervals. My starting point was pi over 2, which means my first point after pi over 2 will be pi plus pi over 2. But that's the same thing as 2 pi over 2 plus pi over 2, which gets me 3 pi over 2. My second point will be a 3 pi over 2 plus another 2 pi over 2. That's going to be 5 pi over 2. Third, and I think we did this one before, so you may see the pattern without me having to write it. The third point will be a 7 pi over 2, and the fourth point will be a 9 pi over 2. So let me plot those. Sorry for not raising that beforehand. So we have a pi over 2. Equidistant will be a 3 pi over 2, a 5 pi over 2, 7 pi over 2, and a 9 pi over 2. Where you're going to start for sine, we usually would start at the origin, but because the graph is shifted to the right pi over 2 units, that's going to be our starting value. So we're going to start at pi over 2. The 2/3 is going to give us a max when we move forward, because the 2/3 is positive. So at x equals 3 pi over 2, the y value will be 2/3. 5 pi over 2, the y value returns to 0. 7 pi over 2 gives us a negative 2/3. And 9 pi over 2 is going to give us a y value of 0 again, which means that our graph will look like this, but this one should be good. We'll move on to the next one, and we only have 2 more to go.